Hi, pre-AP. I'm on maternity leave, well, not really. I mean, I am when you're watching this, but I'm making these videos ahead of time. I'm still very much pregnant. That being said, I'm making these ahead of time, so we'll see how it goes. But anyway, we're starting the new unit, and it's gases. And this is the last unit of the whole school year. After this unit, all you'll have to do is review for your final and take your final, and you'll be good to go. So we have, if you look at your notes, you need to follow along in the notes with me, and they're posting in Google Classroom. I have them set to post every single week, so it should be really easy to find them, and plus they'll be in your notes section in Google Classroom. Sorry. The first thing in your notes is the kinetic molecular theory of gases. And so what this is a model that tries to explain how gases behave, specifically ideal gases. And so we have this idea of how gases should behave, just like we have an idea of how everything should behave. Like there's the ideal teacher, right? And there's all these things that the ideal teacher should do. Do teachers ever actually follow all of those things that you have in your head? No. And then there's the idea of the ideal student or the ideal parent or the ideal child or whatever. We have this idea of how things should interact and they should be perfect. But nothing's actually perfect. So these things are how they're supposed to behave. If you're interested in AP chemistry or you go into college, then they'll talk about how things don't actually follow this. But for this class, we're just going to go with the ideal gas laws, and we're going to learn about it. So we have 4 parts to the kinetic molecular theory. It's just saying how gases behave. And these 4 parts are super important, and that's kind of what we build off of for the rest of the unit. And we'll do calculations and things like that with it. But the first part says that particles are so small that they are considered to be a point mass. And so that means that they have no volume, that these gas molecules that we're breathing in is just a single point. And so they're not big enough to take up any space. Okay? And so then the number 2 says the particles are in constant motion. And their collisions with their container are the cause of the pressure exerted by the gas. And that gas is constantly moving around. And we know this because whenever you set off like a stink bomb or something like that, you can see the wave of smell come across kids. Or if you like have little firecrackers, little smoke ones, I don't know what the point of them is, but you like light them and then they do like blue or green or red smoke or whatever. Whenever those go off, you can see how the smoke travels and it's moving. It's constantly moving. And it slowly disperses, but those particles keep going. And so they are in constant motion moving around. Now then, they obviously collide with things, like gas molecules are colliding with my face right now and my hair and all that stuff. They're not colliding fast enough or hard enough to make a difference. But if I were to be outside and it was really windy, we could see how they were colliding and like moving my hair. But whenever they're in a container, when they're colliding, that's what causes this pressure. And so right now there's some pressure in my water bottle. It's not a lot because I can push in, right? And so because of that, there's not a ton of pressure. That means the gas particles are colliding with my container, but they're not colliding at such a high rate. Now, if I squeeze down below and I change, then now I can't push in, and I've changed that pressure. And so therefore now they're colliding more with the container. So if they collide less, then it's a lower pressure. If they collide more, it's a higher pressure. So these are all the kinetic molecular theory points of gases. And so the first one is that they don't have a volume. The second one is that they move constantly and they collide with their container to cause pressure. And so that's actually the definition of pressure, is those particles colliding with a container. The third one is the particles exert no attraction for each other. So that means that those gas molecules, as they fly through the air and they're colliding with all kinds of stuff, their container, they're moving in constant rate of motion, that they're not attracted to anything. They're not attracted to the container, they're not attracted to each other, they're not attracted to anything, and they just keep moving unfazed. Okay? And then number 4 says the average kinetic energy of the particles is directly proportional to the Kelvin temperature. So to their temperature, but in Kelvin. And we're going to learn about Kelvin. Kelvin's the unit we're going to use for temperature instead of Celsius. That being said, those are the 4 points. I do expect you to know them. Tests and quizzes, worksheets, things like that are all going to be talking about those things. So you make sure that you know those 4 points, okay? And so then we have an ideal gas, which is what I was referring to up above, and it says the gas which behaves as described up above. So we all have this idea of how things should behave, and if something behaves that way, then it's ideal. So same thing for gases. And then we have real gases. And so real gases, they contradict those points above. And so real gases, so point number 1 says that they are a point mass. They don't have any volume. Well, real gases have volume, different size gases, right? Helium's teeny tiny, but then you can have something like neon, which is bigger. You could keep going up. You could have oxygen, which is also bigger. And so in reality, they have different sizes. Carbon dioxide's much bigger. And so they do have volume. And then they also, number 3 says that they have no attraction for each other. They just move around unfazed. But in reality, they do have attraction for each other. Some are positively charged, some are negatively charged. Sometimes things can happen to where we induce a charge on them. And so they are going to be attracted to each other. And so those are going to be the things that real gases deviate from this plan that we have. Okay? So low pressure or high temperature is going to be where they behave the most ideally. So we want low pressures and high temperatures. So when we work these problems, we're going to work problems, and if we have a low pressure, which would be like 1 atmosphere, and then we have a high temperature, which is 273 degrees Kelvin or higher, they're going to behave ideally. They're going to behave much better than they would if we have a different temperature, okay? And so if we have high pressure, low temperature, they're not going to behave ideally. But if you think about it, with low temperatures, what happens to gases when we have low temperature? If things start to drop, okay? So in a state of matter. So if I have steam and I am dropping the temperature, it's eventually going to turn into water, right? And so then it's no longer even a gas. So it makes sense as the temperature gets lower that it's not going to behave ideally because it's becoming more and more and more like a liquid. Okay, so that brings us through the first 3 vocabulary words on your notes, and I'm going to do the rest of them, and that's going to be it for this lesson. And so it says pressure is the force of the collisions of the particles on the walls of the container, which we just talked about. Okay, and then temperature is the measure of the average kinetic energy of a sample. And so remember that other point. So pressure and temperature both go back up to those average kinetic energy points. So pressure is from the point number 2, and then the temperature is point number 4. Because the pressure is the one that we say they're in constant rate of motion, and then they're colliding with their container. And then the 4th one, we say that the average kinetic energy is directly proportional to their temperature in Kelvin. And that's because the temperature is just a measurement of that energy. Okay? Then it tells you how to calculate Kelvin, which is important. So you just take your degrees Celsius and you add 273 to it. We have absolute 0, and this is a theoretical temperature. And so this temperature is just saying that there's no more energy that can be removed from a sample. It is the absolute coldest that anything can be. And so it's 0 degrees Kelvin, which would be negative 273 degrees Celsius. And so we think that that's where all motion stops. That's where all energy, all motion stops. If it gets that cold, nothing is moving. It's theoretical. Then we have STP. We've seen this before when we were working stoichiometry problems, and STP is going to stand for standard temperature and pressure. And so the standard temperature would be 273 degrees Kelvin, and the standard pressure is 1 atmosphere, okay? And so every single problem that we work, you're going to have to work it in Kelvin, and so you're going to have to learn how to convert to Kelvin just by adding that 273, okay? And so then this is where we pick up on some of the problems. So I'm going to end this video, and those are the vocabulary words. You can rewatch this as many times as you need to, and I'm going to make this into an ed puzzle probably for a grade or for attendance or something for your sub. So sorry if you hate that, but it is what it is while I'm on maternity leave. So, and also make sure that you watch it. Hope you all are having a good day, okay? Bye.